Hi, welcome back to Agora Master. My name is Hannah Yang, and today we'll be reviewing the 2021 Canadian Math Kangaroo contest, levels 3 to 4. Let's get started. Problem 1. Eric has 4 bricks. Which of the cubes shown below can he make with his 4 bricks? So, we can see here that Eric currently has 3 dark colored bricks, as shown here. And so what we're looking for in this problem and in the solutions or the options is that we're looking for a model with 3 dark bricks. So A is incorrect because as you can see, there's only 2. B is incorrect because there's only 2 dark bricks as well. But C is correct because we can see that there are 3 dark bricks. Problem number 2. How many fish will have their heads pointing towards the ring when we straighten the line? So here you can see the ring and the other end of the rope. So what we can do from here is we can basically start from this end and then just count the number of fish that are pointing away from that end. And don't count the fish that are pointing towards the end without the ring. So, for example, this fish is pointing away from it. This fish is also pointing away from it. And so is this one. So that brings our count up to 3. If we look here, this fish is also pointing away, but these 2 fish aren't. Because if you actually trace their path, they're looking towards the side without the ring. So they wouldn't count. But this fish is looking towards the side with the ring. And this fish is not. And finally, the green fish is looking towards the ring, which brings our count up to C, 6 fish that are pointing towards the ring when we straighten the line. Problem number 3. When you put the 4 puzzle pieces together correctly, they make a rectangle with an addition. What is the result of this addition? So here we can see that we have 4 puzzle-like pieces where there are 3 numbers and 1 sign. So one thing we need to pay attention to is these little knobs on the edge of this. So this indicates that they fit into these kind of slots. And in this case, that would only work if it was between 3 and 2. And we also know that it's in this specific order because 2 has this edge here, and that usually indicates that they're on the edge or the side of the puzzle. And the same goes for 1. 1 also has that hard stop edge where there isn't a knob or a hole on that side. And that would indicate that it would go to the left of 3. And so if you compute this, you would get 15, which is B, the correct answer. Number 4, Alea draws a picture of the sun. Which of these is a part of her picture? So here we have 5 different options, which are basically snippets from the side of the sun with the spikes here. And our job is to figure out which one of these options actually came from the sun. So we can just go through them one by one. We know that A is incorrect because if you look at the 2 tall spikes here, in all the cases where it appears on the sun, there are never 2 small white spikes next to it. However, B would be the correct answer because as we can see, it appears right here where there's a large dark spike, a smaller grayer spike, a small white spike, and finally the large dark spike again. So that would make B our correct answer. Problem number 5. Ricky participated in a shooting challenge and scored the most points. Which target was Ricky's? So here we see, once again, we have 5 options where it's basically the shooting board and we can see where the shots landed. So for A, we can see that this person scored 10 plus 8 plus 7 points, which equals 25. For B, we can see that the person scored 10 plus 7 plus 7 points, which equal 24. That would make B incorrect because A is automatically larger. C, we can see the person scored 8, 8, and 8 points, which would be 24 again, making C incorrect for the same reason that B is incorrect. And D, the person who had the shooting board of D scored 7 plus 7 plus 8 points, which would be 22 points, which also makes it incorrect. And finally, E, this person scored 9 plus 9 plus 8 points, which brings the total up to 26, automatically making E the correct answer. Problem number 6. A measuring tape is wrapped around a cylinder. Which number should be at the place shown by the question mark? So here we can see a cylinder. And curiously enough, these numbers that are shown directly correspond with each other. They're directly under each other. So if we simply do, for example, 30 minus 9, we get 21. And that means that whatever number is in the third row that we don't know will be the corresponding number below it plus 21, as seen with the 30 and 9 example. So that means that the question mark would just be 27 plus 21, which makes our answer C, 48. Problem number 7. Rosanna has 3 balls in 3 different colors. Balls of the same color have the same weight. What is the weight of one white ball? So here we can see that we have 3 different scenarios with different balls in them. So we can convert these all to equations. So let's call this ball G, or gray. This one will be B, or black, and this one can be W, or white. So we can convert the first scenario into G, a gray ball, plus a black ball equals 6 kilograms. 2 white balls plus a gray ball equals 14 kilograms. And finally, 1 black ball plus 2 gray balls equals 10 kilograms. So since we know that a gray ball plus a black ball equals 6 kilograms, we can substitute it into this equation over here, where it's basically just B plus G equals 10. So we can replace this B plus G, let's cancel it, and then replace it with 6. So instead now it's 6 plus G equals 10. So we can subtract 6 from both sides. And now we know that the gray ball weighs 4 kilograms. And we can substitute it into the second scenario where it's 2 white balls plus a gray ball equals 14 kilograms. Because now we know that it's 2 white balls plus 4 kilograms equals 14, since the 4 is basically just the gray ball. So we can subtract 4 from both sides. So it's 10 equals 2W, divide by 2, and then now we know that 1 white ball weighs C, 5 kilograms, which would be our correct answer. Problem number 8. Anna, Bill, Cynthia, and Della have 1 pet each. The pets are a dog, a cat, a fish, and a hamster. Anna does not have the fish nor the dog. Bill does not have the dog nor the fish nor the hamster. Who has the hamster? So for this, we can paint a visual for ourselves. So let's have A for Anna, B for Bill, C for Cynthia, and D for Della. And at the top, we can write dog, cat, fish, and hamster. So now we have our table. Let's look back at the problem to see what kind of information they give us that can give us clues as to which person has which pet. So we can see that it says Anna does not have the fish nor the dog. So we can cross out those options. And Bill does not have the dog nor the fish nor the hamster. So now that just leaves Bill with the only option of having a cat. So now we know Bill has a cat. But that simplifies things for Anna because now we know that she can't have a cat anymore since Bill already has one. So that means that Anna would have a hamster. So that would make A our correct answer, Anna. Problem number 5. Nisa has 3 different types of cards in the game: apple, cherry, and grapes. She chooses 2 cards from a set of 5 cards and swaps their places. Nisa wants to arrange the cards so that all of the cards with this same fruit on are next to each other. For which set is this not possible? So this is a long and slightly wordy problem. So basically what it's just asking is for which one of the options is it not possible to put all the same cards next to each other with using one move? So we can see that for A, no matter what move we do, the same cards aren't going to end up next to each other with just one move. For example, if we swap this grape and this apple card, then the grapes are together, but the apples aren't. If we try to swap this apple and this cherry card, you discover that the apples are together, but the grapes aren't. So technically, that would make A our correct answer. But just in case, let's check some of the other solutions to kind of get the gist of what we're looking for. For example, B would not be the correct solution because we can see that we can just swap this apple and this grape card so that all the apples are together. And for example, for C, you can just swap this grape and this cherry card so that the apples and the grapes end up together. For D, you can swap this cherry and this apple card so that all the cherries end up together. And for E, you can just swap these 2 cards next to each other so that the grapes and the cherries are together. And that means that all the solutions aside from A are possible to group them together, which is why A would be the correct answer in which it is not possible. Problem number 10. Sophie wants to pick 5 different shapes from 5 different boxes. She can only pick one shape from each box. Which shape must she pick from box 4? So we notice that she wants all the shapes she picks to be distinguished from each other. She wants them to be different. So usually one person might just go through and keep choosing randomly until they find the right solution. But something to quicken this process is to think about the rarest shapes in these boxes. And in that case, it would be the triangle and the diamond. As you can see, the triangle only appears once in box 2. So we must draw it. Otherwise, after that, we're going to end up drawing another shape twice because there isn't another chance to draw the triangle. So that leaves the diamond. The diamond only appears twice in this entire set, meaning that if we can't choose it from box 2, we need to choose it from box 4 because that's the last chance we're ever going to have to choose it. So that would make E the correct answer for this problem. Problem number 11. 18 cubes are colored white or gray or black and are arranged as shown below. The figures on the right show the white and black parts. Which of the following is the gray part? So one thing we can automatically see right off the bat is that the black part only belongs on the top, meaning that we don't need to worry about it at all. So now we just need to worry about the white piece. So as you can see, it extends into both the bottom and top layer. So since we know that the gray piece will only belong on the bottom, we don't need to care about the top piece anymore. Meaning that if we only draw the part of the white piece that goes on the bottom, it would just be 2 squares. And since we can see from here that it's a 3 by 3, that means that the rest would have to be filled out by the gray section, meaning that it would look something along the lines of this, where it's 3 in the first column, and then 2, and then 2, as this is the white piece. So if you look for that in our options, we can see that that fits E. So E would be our correct answer. Problem number 12. In an ice cream shop, there is some money in a drawer. After selling 6 ice creams, there are $70 in the drawer. After selling a total of 16 ice creams, there are $120 in the drawer. How many dollars were there in the drawer at the start? So we can call the starting amount of money X, just give it a variable. So we can convert these words into equations. So the sentence, after selling 6 ice creams, there was $70 in the drawer. So X plus 6i's ice creams equals 70. And so that would mean that X plus 16i in the next sentence equals 120. Now, everything in these equations is the same, except that in the second equation, 10 ice creams got added. So what we can do here is we can do 10i, or 10 ice creams, equals 50, which is the difference between 70 and 120. And so now we can solve for the cost of an ice cream, which is $5. And so we can substitute it back into this first equation of x plus 6i equals 70. So x plus 6 times 5 equals 70 is x plus 30 equals 70. So x would equal 40, which is C, which is also our correct answer. Problem 13. On a tall building, there are 4 fire escape ladders as shown. The heights of 3 ladders are shown. What is the height of the shortest ladder? So we can see that this, with a question mark, is the shortest ladder. And we need to try and find the height of it. But first, we need to find the height of the block it's on. So we can see that this ladder, which is 32 feet tall, is also on the same block and also ends at the same edge or at the same point as this ladder, which is 48 feet tall. So we can simply do 48 minus 32, which would give you 16. And that is the height of the block because that's the difference between this ladder and this one. So now to calculate the height of this ladder, since the shortest ladder and the ladder that's 36 feet tall both end at the same point, we can just do 36 minus 16, which is equal to 20. And that means that the shortest ladder is D, 20 feet tall, and that should be your correct answer. Problem number 14. Noah plays with 3 cups on the kitchen table. He takes the cup on the left, flips it over, and puts it to the right of the other cups. The picture shows the first move. What do the cups look like after 10 moves? So what we notice first is that after 3 turns from the starting point here, all the cups are down. After 6 turns from the starting point, all the cups are up. And after 9 turns from the starting point, all the cups are down again. So one more turn would mean that this cup on the left, which would technically be down, would be turned up once we put it back over here. So that would make our correct answer B, because as you can see, the first 2 cups are down, but the third cup is up. So B should be your correct answer. Problem number 15. 2 lighthouses blink at night to steer the boat safely into the harbor in the dark or in bad weather. One lighthouse flashes every 5 seconds, the other every 7 seconds. How many seconds will elapse between the time the 2 lighthouses blink together and the next time it happens? So for this problem, we can safely assume that they'll automatically start blinking at the same moment. So essentially at 0 seconds, for example. And so from then on, what we need to do is just find the least common multiple of 5 and 7, because that's when they'll both hit the same mark again at the same time. So the least common multiple in these options you see would be 35, which makes D our correct answer. Problem number 16. Eva has 5 stickers shown. She stuck one of them onto each of the 5 squares of this board so that the star is not on square 5. The red apple tomato sticker is on square 1, and the flowers next to both the circle and the triangle. on which square did Eva stick the flower? So if we draw it out here, we know for sure that the red sticker would go in square one. And the arrangement for the flower, circle, and triangle would be that either the circle is on the left and the triangle is on the right, or the triangle is on the left and the circle is on the right. But that shouldn't really matter because we're focusing on the flower. And so if the star isn't on square five, then it means it needs to be in square two. Because if it was on square three or four, it would disrupt this order and basically make it untrue, which isn't possible, meaning that no matter what, the flower will always go in slot four, making D our correct answer. Problem number 17. 7 cards are arranged as shown. Each card has 2 numbers on, with one of them written upside down. The teacher wants to rearrange the cards so that the sum of the numbers in the top row is the same as the sum of the numbers in the bottom row. She can do this by turning one of the cards upside down. Which card must she turn? So if you were to add up all the numbers in the top row, you would get 31. If you added up all the numbers in the bottom row, you would get 35. And as you can see here, the difference is 4. So that essentially means that we need to split the difference, where the bottom row needs to lose 2, but the top row needs to gain 2. And so the answer would be E, or card G, because as you can notice, out of all the options, card G is the only one where between the top and bottom number, there's a difference of 2. So G would be your correct answer. Problem 18. The numbers 1 to 9 are placed in the squares shown with the number in each square. The sums of all pairs of neighboring numbers are shown. Which number is placed in the shaded square? So here we notice that 3 is the smallest number that we are given, and that's the number that we should start off with because we know for sure that in those squares that make up 3, it's 1 and 2. So for example, if we just put 2 and 1, then we can fill this out to be 8. But that's the incorrect answer because as you can see, if we continue more to the left of 2, then that box will be filled out with 5, but there is no 10 to complete it because 15 minus 5 equals 10, which means that instead we would have to change around our order. So instead it's 1 and 2. And here we can see that that works because if that square is filled out with 6, then we can fill that one out with 9. And so the answer would be D, 7. Problem number 19. Each of the 5 boxes contains either apples or bananas, but not both. The total weight of all the bananas is 3 times the weight of all the apples. Which boxes contain apples? So as you can see in the problem, it states that the total weight of all the bananas is 3 times the weight of all the apples. So if the weight of the apples is just represented as A, then 3A equals B, the weight of the bananas. And if we were to add all of these boxes up, it would equal 36 kilograms. And so basically what we can do to convert this into an equation is we can do 3A plus A equals 36. Because this 3A is supposed to be represented by the weight of bananas, but we can instead substitute that out. So now we simply have 4A equals 36. So if we divide it by 4 on each side, then we know that A is equal to 9. So the total weight of the apples is 9 pounds. And now all we need to do is to figure out which boxes add up to 9. And in this case, it would be E, boxes 1 and 4, because 7 plus 2 equals 9. And that's the only match we can find. So E should be your correct answer. Problem number 20. Elena wants to write the numbers from 1 to 9 in the squares shown. The arrows always point from a smaller number to a larger one. She has already written 5 and 7. Which number should she write instead of the question mark? So this is an interesting problem because it's kind of an intricate maze of all these numbers and their relationships to each other. So we can start with this box right here. So if the arrow is coming from the box that says 7, then the only other numbers would be 8 or 9. So you could put either 8 or 9, but then eventually, if you keep following the arrows, you would discover that there's an even larger number, meaning that that one would have to be 9 and this one would have to be 8. And here, as you can see, this one would have to be 4 because all of these boxes all eventually lead up to 4, meaning that they all have to be less than 5. So if it were 1, 2, or 3, then it means that it wouldn't work out. And so because we know that all of these boxes need to be under 4, then that leaves this final one to be D, 6, which should be your correct answer. Problem 21. The sum of the digits of a given two-digit number is 12. If the digits exchange their places, then the new number is 18 more than the original one. What is the product of the digits of this number? So there are two ways to go about this. The first one is a classic guess and check, where basically you just go down the list of numbers that sum to 12, and then eventually you'll find the correct answer. So if you were to go down this path, then you must keep in mind that you want a pair as close to 6 and 6 as possible. Because even though 6 and 6 itself doesn't work because it's just 66 and 66, if you go too far down, for example, like 9 and 3, then the difference will be way too big. So the next pair closest to 6 and 6 would be 5 and 7, which if you multiply them gives you 35, and that is the correct answer. There is another more mathematical way to go about this. So let's say the original number is x and y, is xy, where x is the tens digit and y is the ones digit. Now, if you were to represent this in an equation, you would want to multiply 10 by x, because for example, if you wanted to represent 91 in an equation, but you didn't know it was 91, you wouldn't do 9 plus 1. That's 10. That's so far from 91. So what you would want to do instead is 10 times 9 and then plus 1. And that's what we're going to do here. So to convert this into an equation, we can simply do 10x plus y. And then if you switch the digits around, it would be minus 10y plus x. And we can set that equal to 18 because we know that the difference between them is 18. So now we can simplify, so it's 9x minus 9y equals 18. If you divide both sides by 9, then you get x minus y equals 2. Now, this is important because remember that before it said that the sum of the digits of a given two-digit number is 12. That means x plus y equals 12, and x minus y equals 2. So we can kind of subtract these equations from each other. And what we'll get from that is that the y's will cancel. And it'll be 12 minus 2. So then we get 2x equals 10. So we know x equals 5. And so then the other digit would naturally be 7 because 5 plus 7 equals 12, and 12 minus 5 equals 7. And if you multiply 5 and 7, then you get 35 again. So C should be your correct answer. Problem 22. George has some marbles in a box. Every turn he removes half of the marbles, adds 2, and then doubles the remaining marbles. After 35 turns, there are 148 marbles in the box. How many marbles did the box contain in the beginning? So we need to find some sort of pattern to this. So let's make a table. So this is, so turn, the beginning equation, during the turn, and then the end result. So let's say it's turn 1, right? So you would naturally begin with x, which is just the starting number of marbles. So then you would do 2 times 1/2 times x plus 2. And then you would get x plus 4. And your end result would be x plus 4. If you keep doing this over and over again, you will notice that at some point, it's just adding 4 each turn. And that's a really important um, pattern that we want to notice here. So if we do 35 times 4, because there are 35 turns, and then plus x equals 148, then you should end up with x equals 8, meaning that the answer would be A, and that should be your correct answer. Problem 23. Martin placed 3 different types of objects, hexagons, squares, and triangles, on 3 sets of scales as shown. What does he need to put on the left-hand side of the third scale for these scales to balance? So if we look at the second scale, if we just take away the hexagons, we can see that 1 triangle equals 5 of the squares. And this is really important because now we can substitute that into the first scale, where now we simply have 2 hexagons equal 6 squares because we replaced the triangle with 5 squares since they're the same weight anyway. So we can just divide it by 2, and now we know that 1 hexagon equals 3 squares. And that's really important for the last equation because we can replace all of the shapes with just squares. So on this side, there would be 10 squares, and on this side, there would only be 9. So from here on out, we now know that in order to balance it, we simply need to add 1 square to that side. So A should be your correct answer. Problem 24. Bird has a shape made of 4 glued squares. She places the shape on a grid figure so that it completely covers 4 of the grid cells. Every time Berta does this, she increases the number in the 4 covered cells by 1 as shown below. Starting with 0 in every cell of the grid, Berta places her shape several times as described. In the end, Berta hits some numbers with circle stickers. What is the largest number in her last figure? So this problem is a bit of a tedious one. And that's because you kind of have to figure out how many times each circle has been overlapped. So first off, you want to start off with the numbers that can only be part of 1 square so that there's no chance for overlap. And we can immediately tell how many times that square has been overlapped. For example, this one that I'm highlighting in black. The number at the corner here, 3, indicates that this square has been overlapped 3 times, all because there is no other square 3 can necessarily be a part of. There's no other branch that 3 can join other squares in. Therefore, it only represents the number of times that this 1 square has been overlapped. Now, let's take a look at 2 over here. So 2 is in the same situation as 3, where it basically just indicates that this square has been overlapped 2 times. And so this is just trying to get the gist of how this works, which means that this little circle next to 6 would be 5 because it's been overlapped 3 times at the top and 2 times at the bottom. Now, since the spot next to 6 is 5, that means that this square has been overlapped once because that would give 6 the extra 1. Otherwise, it would just be 5 as well. But 4 is just as same as 3 and 2 as we mentioned previously. So that means that this spot would be 5, this spot would be 3, and this spot would be 3. And we don't know what these 2 spots would be yet. Now you want to jump back to the bottom. where we kind of use the same logic. So you see another 2 down here means that this space has been overlapped twice. And a 1 here indicates that this certain square has been overlapped once. So this would be 1 and then 3 because it's been overlapped twice and then once. And then here is where it gets interesting. There's a 7. And as of right now, the 7 is the largest number in the entire grid. But that's going to change because 7 basically means that this square that contains these 3 blank spots and the 7 has been overlapped 4 times. Because we know that since he's been overlapped twice with the bottom left square and once with the bottom right square. That means that the only other square he can be a part of is this one, which indicates it's been overlapped 4 times. So now we can fill in our values, where this would be 6 because it's 2 and 4. This spot would be 9 because it's 4. Okay, sorry. Because it's 4 here, 1 here, and then 4 again. And then this spot would be 8 because it's 4 and 4. This problem is a bit difficult to wrap your head around, but once you get the basic gist of it, you can kind of go through the entire grid and just fill in the blanks. So then your correct answer should be D, 9.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!